Hi, welcome to Allen High School's discussion of solutions at the PreAP chemistry level. We're talking about concentrations, and in particular, we're looking at the concept of dilution. And we're going to be dealing with molarity for dilutions. Okay. Now, dilution is the process of making a solution less concentrated. An example from prior knowledge is if you went in the freezer section, you might buy your OJ in a concentrated form in the freezer. So you buy this can of concentrated orange juice and you put it in a pitcher with water. You dilute it. So to concentrate something means to remove the water or the solvent. To dilute it means to add the water or the solvent. Now, if we look here, which is more concentrated, the one that is more concentrated is the one with the most moles per volume. And if you count the little spheres representing the moles, you'll find that we have the same moles, but this is in a smaller volume. If it's in a smaller volume, it's more concentrated. Just like your OJ in the can is in a smaller volume than your diluted OJ in the big pitcher that you have. The more dilute is the one with more volume. Same solute, but more volume in that case. Okay, when we add solvent, we decrease the concentration, and we'll be focusing on molarity. So that means we're going to decrease the molarity of the solution and make the solution more diluted. Now, the key here on these is looking at some words about the volume. You'll see volume given up to a given volume, or you will see added a given volume. So you have to be careful in order to find V2. All right. Now, this is a pretty simple formula, and so many people forget about it. But if you see two volumes or molarities involved, if you list your givens, you're going to see volume added to volume. When you have volume added to volume, you got a voom voom. That's going to be your clue. Volume added to volume, voom voom. All right, let's look at the first one here. It says, what is the molarity? Now, I messed this up. I had to redo this video because I got my volumes right. Notice that it's 50 milliliters of that molarity. Now, it doesn't matter what we call V1 and V2 and M1 and M2 as long as we link them properly, and I messed that up. So read carefully. 50 milliliters of a 3.79 molar solution. Notice that it's being diluted to a total volume of 2 liters. So V2 is going to be 2.00 liters, and I want to know my M2. Now, much like Boyle's law and Charles' law and so forth, what's important is we have the same units. So I'm going to convert that volume to 2,000 milliliters. Okay? Now, I'm running out of room, so I'm going to use up a little bit of this space here, and then I'll erase that. So to plug into voom voom, notice I added volume to volume. You've got 2 volumes, 2 molarities involved. I have 50 times 3.79, not divided. I don't know why people do that, but they do. My new volume is 2,000 milliliters, and I'm solving for M2. And if you solve for M2, you're going to get 0.0948. And I took it to 3 sig figs because that was the fewest there. And don't forget your units. Okay? Now, let's take a look at the next one. That was pretty much a straight shot in. But be careful with this next one because we have a liter, and you notice it says that 7 liters was poured into that 1 liter. So I have a liter, and I poured in 7 liters. What that means now, and I'm going to solve this one down here, my volume 1 is 1 liter. My volume 2 is 8 liters. That's, pretty much all you have to do is read that very, very carefully there, because my volume 2 is my final total volume. So my molarity in that 1 liter was 3.8 molar, and I want to know what my new molarity is, and that's my unknown. At this point, I just plug and chug. So I have volume 1 times molarity 1 is equal to volume 2 times molarity 2. The tough part was seeing that my volume 2 was the sum of the 1 plus the 7. And if I solve that, I get a 0.48 molar solution. Would be my new molarity after I diluted it by adding water. All right, we're going to shift gears and talk about colligative properties in our next series of videos. So until then, this is signing off.